So very good morning to one and all. This is me, Karthik, from Kogonadu College of Engineering and Technology from the Department of Computer Science and Engineering. So we are going to see about the subject CS8791 Cloud Computing, Unit 3. Already we have seen 2 units. This is your third unit. So unit name is cloud architecture, services, and storage part. So in first 2 unit, we have seen about the introduction, and second unit, we have seen about cloud enabling technologies. And this is your third unit. And third unit, we are going to see about cloud architecture and what are the different types of architecture there in services and storage part, right? So we have layered cloud architecture design, NIST cloud reference architecture we are going to see, and public cloud and private cloud and hybrid clouds and different type of services. What are the services there in cloud computing? In first unit, we have seen some about the basics. Here we are going to see in detailed in this third unit. Architectural design challenges, cloud storage, storage as a service, advantages of cloud storage providers. What are the cloud storage providers we have? And S3 principle, which is also related to cloud storage part. All right. So we are going to see about NIST cloud reference architecture. So we are seeing about different types of architectures in cloud computing. One of the architecture is so we'll see about the first architecture, layered architecture design. So already I've said before first unit and second unit, we have seen about introductions, and second unit we have seen about cloud enabling technologies. What are the technologies we have? In third unit, we are going to see about what are the architectures we have, right? So architecture means in cloud computing, how the data is being processed and how the data is, what are the services are there, how the services is being processed in your cloud architecture, and that services is how returned back to the consumers. So architecture is the detailed part which take about all the activities in your cloud computing. See, the architecture of cloud computing categorized into 4 different layers. So each layer have their own functionalities. As we seen in networks we have C7 layers as a basic of computer science. We have 7 different layers, right? At the same time, in cloud computing, we have 4 different layers. So first one is physical layer, application layer, infrastructure layer, and platform layer. So these are the 4 basic layers in cloud architecture design. So cloud architecture, we have different types of architecture. First, that is layered cloud architecture design. So this is the diagram of cloud architecture design. So left hand side, we have what are the services are there and what are the services are processed in each layer. So in right side, we have an example for each layer. So basic, we have, it is divided into, as I said before, it is divided into 4 types: physical layer, application layer, infrastructure layer, and platform layer, right? So at last, we have a basic layer, that is physical layer or a hardware layer, which is similar of both physical layer and hardware layer is similar. In physical layer and hardware layer, as I said, in networks, physical layer it related to infrastructure and it is hardware part, right? So same like here, it is related to hardware part. What are the CPUs and memory devices, and what are the bandwidth required for that implementation cables? It is these kind of data will be discussed in hardware layer. As left hand side, see that we have infrastructure as a service. So generally, what is infrastructure? As I said before, we have 3 basic services in cloud computing: software as a service, platform as a service, and infrastructure as a service, right? As infrastructure service, we have how these services are being implemented. As I said, we cannot depend upon for a small scale industries, they cannot be able to depend upon full infrastructure at the starting itself. They cannot be able to implement. So it has to be given as a service. That is the main advantage of your cloud computing. So first, infrastructure, how storage part is provided, how CPU and memory devices, disk management and bandwidth, these all given as a service to the user. That will be in your basic layer, that is in physical layer or hardware layer. So right side we have examples who are the basic or major cloud service providers. One is Amazon, and data centers, we have different data centers at different locations, and IBM. These are the biggest examples of infrastructure as a service. Next layer comes your platform service layers. In platform, what are the different kinds of softwares has been used, that is software framework, that will be discussed in your center layer. That is software is how it is different, it is implemented in what are the different programming languages, that is Java, Python, .NET, storage, and what are the different platform service providers are there. In right hand side it is given, that is Microsoft Azure. All of you know about what is Microsoft Azure. And Google App Engine. Google App Engine provides you the environment for creating different platforms or different applications. It is given you, right? Google App Engine will helps you to create your own applications. So for that environment it will give that. So that is a platform as a service. So for developing our own application, we need some interfaces or some environment for developing applications. That is platform as a service, which is given by Microsoft Azure, Google App Engine, and Amazon S3. That is for storage part. Third is application layer. Application layer will comes under very first layer, as I said, in networks. So networks also application will be your top layer. Here in cloud services also application layer is a top layer. Through this, users are able to access their services, right? So that is your application layer. Here, what are the different kinds of services are being provided by your Google App Engines and Facebook, YouTube's. There are a lot of services will be given by our different cloud service providers as a software as a service. So we cannot depend upon all this. So we can pay the money and we can we can get software and platform and infrastructure as a service. All these are the biggest investments in real time. So all the software or small scale industries cannot depend upon this. They cannot able to spend a lot of money on this. So they are providing these kind of services in online. That is the biggest advantage of your cloud computing. So hardware layer, we'll discuss about detailedly. Hardware layer, physical resources of the cloud computing are managed in this layer, including physical servers, routers, switches, power, and cooling systems. So all this will comes under hardware layer. So hardware, without this, you cannot complete your hardware, that is infrastructure. Without servers, without routers, without switches, you cannot complete this. A data centers usually contains thousands of servers that are organized in racks and interconnected through switches, routers, and other fabrics. So all you know what is data centers, and data centers, it is located in different parts. For every country there is different data centers. So for that we cannot implement that for a software industry. If it in case it is a small scale industry, for a large scale industries it is not a problem. For small scale industries, small scale industries, it is a problem. They cannot able to implement the data centers at different locations. But at Google, if you imagine that Google has different data centers at different locations, because they are the largest cloud service providers. So at different locations, if you want maintain service, that can be organized in racks and interconnected through switches, routers, and other fabrics. Other issues at the hardware layer include hardware configurations, fault tolerance, traffic management, power and cooling resource management. So these are the issues which has been faced in hardware layer. Infrastructure layer, the basic purpose of infrastructure is to deliver basic storage and compute capabilities as standardized services over the internet. So it is also known as the virtualization layer. So infrastructure, the main issue when you're going to start a company, it is a service. Biggest question is how to manage your service, how to manage your storage part, and how to manage your manpower. These are the main question marks if you are starting a company. So cloud computing will answer for all these questions in a remote mode, that is as virtualization they can be able to provide you. So virtualization layer creates cluster of storage and computing resources by partitioning the physical resources using virtualization technologies such as NKVM and VMware. So there are a lot of examples for that. This layer is an essential component of cloud computing since many key features such as dynamic resource assignments are only made available through virtualization technologies. So infrastructure, it is on-demand provisioning of infrastructure resources, usually in terms of virtual machines. The cloud owner offer IaaS services as soft infrastructure service providers. A biggest example is, as I said before, I have mentioned here, that is Amazon EC2, that is Amazon EC2, GoGrid, and Felix Scale. These are the examples. All you hear about Amazon EC2 is the biggest cloud service providers for infrastructure as a service. So all you cannot depend upon a particular company for developing an infrastructure. So if in case it is a big industry, it is not a problem for infrastructure as a service. But tier 2 small scale industry is a very big problem. They cannot invest more amount in infrastructure as a service when they are going to start a company at the first time. So after development of the company, after 3 years, if they got profited, they can be able to manage. So these services are provided in infrastructure service in cloud computing, which you provide an infrastructure as a service, which helps for many small scale companies. So next, top platform as a service. So it is built on the top of the infrastructure layer. So first your hardware layer, infrastructure layer. On that we have infrastructure layer. We have on the top of the infrastructure layer, we have platform layer. So it consists of operating system and application frameworks. So this environment consists of operating system, different operating systems, and it provides you different frameworks. So if I want to develop a software application or application, so I cannot be able to develop full parts. So if already it is framework created, I can be able to easily manage that applications. So Google application is the biggest example for that, platform as a service. So this platform as a service will provide you an application framework for developing your own applications. So the main purpose of your platform layer is to minimize the burden of delaying applications directly into virtual machine containers. So the biggest example, your cloud service providers, that is we have different cloud service providers. Under that, the platform layer, Google App Engine operates as a platform to provide APIs. So it will supports different application layer, supports application interfaces for developing storage part, databases, and business logic of typical web applications. So the advantages of using platforms or services, we only need to understand the layers lower the one we are looking on. So each layer is replaceable by an equivalent implementation with no impact on other layers. So layers are used for standardization. A layer can be used by different high level layers. The disadvantages is as simple. So before that, this is the architecture we are using now. How we have used in 1960s and 1970s before the development of internet and all. We have one tier. All you heard about one tier architecture, two tier architecture, and three tier architecture, right? This is overnight. It is not overnight development. So although the software development started during 50s, it was during the 70s and 60s that is effectively born as we know it today. As the activity of building applications that can be delivered, deployed, and used by others. At this point, however, applications were very different than today. See, what are the architectures we are using now? It is not the overnight development. So our development all is started from 50s, 60s, and 70s. So after that, we have used one tier architecture, two tier architecture. Slowly, it has been developed, and what are the sophistications now we are enjoying that software now in cloud computing. So this is your one tier architecture. Directly we have client systems, and it is user interface business logic data. So only one tier or one layer will be there. As simple, while these applications are very simple, that it is not scalable. So already I said, so scalable is the important factor in cloud computing. So without scalable, it is not able to work. So scalable, right? So latest during 80s and 90s, the enterprise applications came into life. So after this, we have started using enterprise applications in our environment, and we started having different several users in the company using desktop systems who access the computer applications through the internet. So sorry, through the network. So this is your two-tier architecture. Our one-tier architecture has become two-tier architecture. This is user interface, second business logic interface, and last we have data part. So all this is connected to your infrastructure. So base layer will be your data, that is DBMS. There only our all the data is getting located. Your last part, that is your storage part. Next, your business logic layer and user interface layer. So this is effectively shifted our two-tier applications, where client would be a rich client applications used at the application interface, and the servers would have the business logic and data source. The architecture pattern solves the scalability problem. As servers could use the applications independently, we would just need another just desktop computer, install the client application net, and that was it. So however, if you could have a few hundred or just even a few tenth of the clients and would want to update the application, it would be a high complex operation, as we if you want to update the clients one by one. So if it is a few systems, few or 10 clients, and we want to update application, would be a high complex operations. So before cloud computing or before two-tier architecture, so there is a scalability problem. So after the development of these applications and all, so scalability does not have high impact factor nowadays. So if you want to have more your architecture should be able to process more number of clients or more number of services at a time. So they cannot depend upon a certain number of applications in a certain time. So your cloud computing should be able to, your architecture should be able to process different and number of services at a time. So later in mid 90s, that is roughly between 95 and 2000, this was a generalized shift to our cloud context. The increase of in application users, application complexity, and infrastructure complexity, we end up seeing an evaluation of the large layering scheme. So slowly our architecture has been changed from 60s and 70s and 80s, and it has been also changed in 90s. So through slowly day by day, our in over centuries, our architecture has been changed. This is your three-tier architecture which has been used now. That is user interface layer. That is next domain model. That your second entire layer. Third tier is your data layer. That is your DBMS. That is database server, search server, and third party application. Apart from this, what are the application uh, APIs you are going to use? And persistent domain model, application layer, presentation layer, and user interface. So these are the three-tier architecture we are going to use in cloud computing. So this is your three-tier architecture pattern. This is also known as N-tier. It is a scalable solution and solves the problem of updating and clients as user interface lives, and it is compiled on the server. So these are the different types of layers which has been increased in year by year. So first we have used one tier architecture, and second we have used a two tier, and it is converted into N-tier architectures. So latest after 2000s, you have published his book Domain Driven. That is what are the different types of layers for a software system. This is a small information we have know, that is user interface, application, and domain, and infrastructure layer. So the same layer has been slightly altered by this every events. So but we are using three-tier architecture, which is divided into first user interface layer, second presentation, application and domain model, and persistent, last three-tier your database layer. So which is all it is connected to your infrastructure layer. So without infrastructure we cannot able to do. So these are the one of the different topics in your cloud computing, right? So cloud computing, it offers you different types of services and cloud architectures in nowadays. So this layered architecture is one of the type.